We're going to start with the Corda ledger. So just as a introduction, and I think it's useful to think of the Corda network as a fully connected graph where all the nodes on the graph are actual Corda nodes, and the edges represent the potential for these nodes to communicate. And it's worth noting that I emphasize potential because these edges or these connections do not have to be persistent. At the networking level, we're using persistent queues. So very similar to email. If your recipient is offline, then the messages will just queue up on the outbound queue until the recipient comes online. And as well, it's worth noting that because there's no broadcast or gossip network, you have to specify the recipient of your message. So you can control who sees what and when they see it. So it's up to a node whether they want to communicate with another node. How do nodes discover each other? Well, there's a network map service, and you can think of the network map service as simply a phone book which publishes a list of peers or nodes on the network with some metadata about who they are and what services they can offer. And we'll talk a bit more about services nodes can offer later. But crucially, the main point to take away from this is that Corda is different to all other DLT that uses global broadcast and gossip network to propagate data around the network, whereas Corda uses point-to-point messaging. So the Corda ledger from a data perspective, I think it's useful to visualize it as a Venn diagram. So you can see here we've got a bunch of sets: Alice, Bob, Carl, Demi, and Ed, and the named set represents facts that that named entity knows. So you can see here we've got a set representing Alice or the facts that Alice knows, and we've got a set here representing the facts that Bob knows. Where those sets intersect, we say the intersection contains shared facts that both Alice and Bob are a party to, or Bob and Carl are a party to. And those shared facts are on the ledger, or on the Corda ledger. So you can think of the whole ledger as everything that is shared. So the intersections between all, the union of all the pairwise intersections between all of the nodes. But obviously you can see that Alice doesn't have an intersection with Ed. That's because Alice and Ed don't share any facts. So they're not in consensus about anything. Anything that's outside the set is not a fact that any of these named entities know. But it is worth noting that you can have a fact that is not necessarily shared on the ledger, and we'll explore that in a little detail in the following slides. So it's worth noting that the ledger is a subjective construct from each peer's point of view. So that means there are no omniscient peers. There are no peers that see everything. So if you look at the ledger from, say, Alice's point of view versus Demi's point of view, they will see a different set of shared facts on the ledger. And a good way to illustrate this is by just using some very simple set notation. So you can see here, if we take these numbered circles as shared facts on the ledger, so we've got 1 to 9, these coloured circles. So Alice and Bob are in consensus about 1 and 7, Bob and Carl 5 and 6, etc. We can see that not all parties have the same sets. So you can see Alice's set differs to Bob's, but Alice is a subset of Bob's. And we've got Carl, who is in consensus with 3 other parties, so there's more shared facts there. Then there's Demi and Ed. So this is exactly how the Corda ledger works from a Corda node's perspective. Though there are a couple of subtle differences. So actually in Corda we say that data propagates around the network on a need-to-know basis. So this view here is a slightly simplistic view of how data propagates around the network, and you'll see when we touch on verification consensus why this has to be the case. But for now, I think this is a useful way to visualize how data is shared around the ledger. So crucially here, Ed, Carl, and Demi can't see the shared facts between Alice and Bob. So what does this ledger look like from a Corda node's perspective? Firstly, there's no central ledger with agency operating on behalf of all of the nodes on the network. So instead, each peer on the network maintains a vault of facts, And you can think of this vault as a SQL database. In fact, it is a SQL database, but for the purposes of this discussion, it's maybe easier to think of it as just a table, and the table contains rows, and these rows are shared facts. So where there's a row in an identical row in each node's table, you can see here row 1 and row 7 are identical for Alice and Bob. You can say there's a shared fact between both Alice and Bob. But obviously, not all facts need to be shared with other peers. That's because communication occurs on a point-to-point basis only in Corda. And here you can see that there's a number 11, which is a square, and it's a fact which is in Alice's vault, but not Bob's. And this is actually just a unilateral. I call it a unilateral fact. It's not a bilateral shared fact, and it's something that Alice could potentially use later on. It could potentially be an offer to purchase something that has not actually been sent to the counterparty yet. So it's important to think of each node having a vault, and the vault contains facts. The majority of those facts will be shared with other nodes on the network, and as such, each node that is a party to that shared fact will have an identical row representing that shared fact in their vaults. So I'll say that the key learning here is that the Corda ledger is subjective from each peer's perspective.